Hi Jets, welcome back. It's Apple and Annie again, and in this video we will cover sections 2.1 to 2.4. Let's get started.
Moving on to 2.1 on our properties and operations. First, defining the commutative property of addition. It states that in a sum you can add the numbers in any order. In numbers, it is such that 4 plus negative 7 is equal to negative 7 plus 4. Algebraically, A plus B is equal to B plus A.
Second, defining the commutative property of multiplication. It states that in a product you can multiply the numbers in any order. In numbers, it is 8 times negative 5, which is equal to negative 5 times 8. Algebraically, it states AB is equal to BA.
Third, the associative property of addition states changing the grouping of the numbers in the sum does not change the sum itself. Numerically, it can be parenthesis 9 plus 6, close parenthesis, plus 2 is equal to 9 plus parenthesis 6 plus 2 and close parenthesis. Algebraically, it is parenthesis A plus B and parenthesis plus C is equal to A plus B plus C in parenthesis.
Fourth, the associative property of multiplication states that changing the groupings of the numbers in a product does not change the product itself. In numbers, it is parenthesis 3 times 10, close parenthesis, it is equal to 3 times open parenthesis, 10 times 4, close parenthesis. Algebraically, it is parenthesis AB times C is equal to 8 times parenthesis BC.
Fifth, the identity property of addition states that the sum of a number and its identity 0 is a number. Numerically, negative 6 plus 0 is equal to negative 6. Algebraically, A plus 0 is equal to A.
Sixth, the identity property of multiplication is the product of a number and the multiplicative identity 1 is a number. Numerically, 4 times 1 is equal to 4. Algebraically, A times 1 is equal to A.
Now let's move on to some example problems.
Evaluate the expression when A is negative 3 and B is 10.
First, B times 12A. We can substitute 10 for B, and 12 times negative 3 substituted for A is the same as 10 times negative 36, which gives us negative 360.
Second, 17 plus A plus 9B. The expression is the same as 17 plus negative 3 substituted for A plus 9 times 10, which was substituted for B. If we simplify it, it becomes 17 plus negative 3 plus 9 times 10, and 17 plus negative 3 is 14. So it is 14 plus 90, which gives us 104.
Third, 23 minus A plus B is the same as 23 minus negative 3 plus 10, which is the same as 23 plus 3 plus 10, which gives us the final answer of 36.
Next, section 2.2 on the distributive property, first defining some key terms.
An example of distributive property numerically can be 4 times parenthesis 6 plus 3 is equal to 4 parenthesis 6 plus 4 parenthesis 3.
Algebraically, it can be A times parenthesis B plus C is equal to AB plus AC.
Second, equivalent numerical expressions are expressions that have the same value.
An example can be 2 times parenthesis 90 plus 60 and 2 times parenthesis 90 plus 2 times parenthesis 60.
Third, equivalent variable expressions are two variable expressions that have the same value for all variables.
Next, on some example problems using the distributive property to evaluate the expression.
First, 6 parenthesis 1 plus 2 close parenthesis. This is the same as 6 times 1 plus 6 times 2, which is 6 plus 12. The final answer is 18.
Second, negative 8 times open parenthesis 1 minus 2 is equal to negative 8 times 1 plus negative 8 times negative 2. This is negative 8 plus 16, which gives us 8 as a final answer.
Third, open parenthesis 3 minus 7 close parenthesis times 4 is the same as 4 times 3 plus 4 times negative 7. This can be evaluated and simplified to 12 plus negative 28, which gives us negative 16 as a final answer.
Moving on to our third section on simplifying variable expressions.
First, let's define some key terms. Also refer to 5x plus 4x plus 7 for examples below.
A term is part of an expression that is added. Some terms can be 5x, 4x, and 7.
A coefficient is a number part of the term such as 5 and 4.
Constant terms are parts of an expression that has a number but no variable such as 7.
Like terms are terms that have identical variable parts like 5x and 4x for the example above.
Now moving on to some example problems.
For the given expressions, identify the terms, coefficients, and constant terms, then simplify the expression.
The first expression is 3y plus 12 plus y plus 49. The terms are 3y, 12y, and 49. The coefficients are 3 and 1. The constant terms are 12 and 49. And the simplified expression is 4y plus 61.
The second expression is 10x plus 100x plus 3x minus 2. The terms are 10x, 100x, 3x, and negative 2, while the coefficients are 10, 100, and 3. The constant term is negative 2, and the simplified expression is 113 minus 2.
Finally, on the last section, variables and equations.
Now defining some key terms.
An equation is a mathematical sentence formed by placing an equal sign between two expressions.
The solution of an equation with a variable is a number that produces a true statement when it is substituted for the variable.
Last, solving an equation means finding all solutions of an equation.
Next, moving on to some example problems.
Tell whether the given value of the variable is a solution of the equation.
First, 4x plus 3 is 11 when x is 2. When we substitute 2 for x, the equation is 4 times 2 plus 3 is 11. 4 times 2 is 8 plus 3 is 11, so the variable is the solution of the equation.
Second, 24 minus x is equal to 90 given x is negative 80. If we substitute negative 80 for x, the equation is 24 minus negative 80 is equal to negative 90. Simplifying the equation, 24 plus 80 is negative 90, which is not true, so negative 80 is not a solution for the equation above.
Awesome job, Jen!
You made it halfway through the chapter.
Thank you for tuning in, and see you next time for sections 2.5 to 2.7.
Bye!
Bye!